morning. I'm Devasena. In this lecture, we are going to discuss about bipolar junction transistor. This topic is present in the subject electronic devices and circuits. Let us discuss about the bipolar junction transistor in detail. Bipolar junction transistor. Bipolar junction transistor BJT. The bipolar junction transistor was developed by Dr. Shockley along with Bell Laboratories in 1947. For the first time, this component was used in commercial venture in 1948 when the Bell system employed transistor circuits in the telephone switching circuits. Since then, it has revolutionized the field of electronics. The BJT is a main building block of all modern electronic systems. It is a three-terminal device whose output current, voltage and or power are controlled by its input current. In communication systems, it is used as a primary component in the amplifier. An amplifier is a circuit that is used to increase the strength of an AC signal. In digital computer electronics, the BJT is used as a high-speed electronic switch that is capable of switching between two operating states, that is open and closed. Let us see the BJT transistor with the day-to-day life simple analogy. Here is a representation of the BJT. The BJT is a current control device, and let us see an day-to-day life example. In this diagram, we are having a tap. In one end, the tap is having the water. In another end, with the help of the knob adjustment, the flow of water in the tap is being controlled. So, the control knob is analogous to the base, flow of water is analogous to the emitter, and the water that is available at one end of the tap is represented as the collector. Flow of electrons in a transistor representation is shown here. Transistor construction. A transistor consists of two p-n junctions formed by sandwiching either p-type or n-type semiconductor between a pair of opposite types. There are two types of transistors. They are NPN transistor and PNP transistor. NPN transistor representation is shown below. Here is another way of representing NPN transistor. PNP transistor representation is shown below. Another way of representing a PNP transistor. Transfer resistor, that is transistor. The transistor has two junctions. One junction is forward biased and the other junction is reverse biased. The forward biased junction has low resistance path, whereas a reverse biased junction has a high resistance path. The amplification in the transistor is achieved by passing the signal from a region of low resistance to a region of high resistance. This concept of transfer of resistance has given the name transistor, that is transfer resistor. The prefix trans means the signal property of the device, while resistor classifies it as a solid element in the same general family with resistors. Transistor uses. A bipolar junction transistor has a very important property that it can raise the strength of a weak signal. This property is called amplification. Because of this property, the transistor is one of the most widely used semiconductor devices. The transistors are used in digital computers, satellites, mobile phones, and other communication systems, etc. Regions of transistor. A bipolar transistor has three regions known as emitter, base, and collector. All these three regions are provided with the terminals which are labeled as capital E for emitter, capital B for base, and capital C for collector, respectively. Emitter region of transistor. Emitter is the region situated in one side of transistor which supplies charge carriers, that is electrons or holes, to the other regions. The emitter is a heavily doped region. Base region of the transistor. Base is the middle region that forms two p-n junction in the transistor. The base of the transistor is thin as compared to the emitter and is lightly doped region. Collector region of the transistor. Collector is a region situated in the other side of the transistor, that is side opposite to the emitter, which collects charge carriers, that is electrons or holes. The collector of a transistor is always larger than the emitter and base of a transistor. The doping level of the collector is intermediate between the heavy doping of the emitter and the light doping of the base. Junctions of transistor. The transistor has two junctions, that is, it is like two diodes. The junction between emitter and base may be called emitter base diode or emitter diode or emitter junction J suffix E. The junction between base and collector may be called collector base diode or collector diode or collector junction J suffix C. BJT representation using diode. Here is a representation. The BJT is represented with the help of two diodes connected back together. Here we know that the BJT is having three terminals. They are emitter, base, and the collector. The diode's cathode is connected together, that forms the base, and one end of the diode anode is connected and called as emitter, and the other end of the diode's anode is connected and it is called as collector. PNP transistor and its symbol representation is shown below. This diagram represents the PNP transistor. PNP transistor is having three terminals, emitter, base, and collector. The emitter terminal is made up of P region, base terminal is made up of N region, and the collector terminal is made up of P region. In this PNP transistor, emitter base, at emitter base we have emitter junction, and at base collector we have collector junction. This is indicated here. This is the symbol of the PNP transistor. In this PNP transistor, the arrow mark is flowing towards the circuit. NPN transistor and its symbol representation is shown below. Here is a representation of a NPN transistor. NPN transistor is having three terminals, emitter, base, and collector. Emitter terminal is made up of N region, base terminal is made up of P region, and the collector terminal is made up of N region. And here we have between emitter and base, emitter junction is there, and between base and collector, collector junction is there. It is indicated here. Here is the symbol representation of NPN. In the NPN transistor, at the emitter terminal, the arrow mark is pointing outside the circuit. Transistor biasing. For proper operation of a transistor, the two p-n junction must be correctly biased with external DC voltages. The resistance of the emitter diode, that is forward biased, is very small as compared to the collector diode. It is reverse biased. Therefore, forward bias applied in the emitter diode is very small, whereas reverse bias on the collector is much large. Modes of operation of BJT. In order to operate transistor properly as an amplifier, the two p-n junctions should be correctly biased with external voltages. Depending upon external bias voltage polarities used, the transistor works in one of the three regions as active region, saturation region, and cutoff region. Transistor biasing, saturation region. If the emitter base junction and the collector base junction are forward biased in a transistor, means the transistor operates in saturation region. The emitter and collector currents are large in saturation region. Transistor biasing, cutoff region. In a transistor, if emitter base junction and collector base junction are reverse biased, means then the transistor operates in cutoff region. In this cutoff region, the currents are due to thermally generated minority carriers. Transistor biasing, active region. The third type of bias is most commonly used to operate the transistor as an amplifier. In this active region, the emitter base junction is forward biased and collector base junction is reverse biased. Here is a representation of application of a transistor as a switch. When the switch is closed, current is flowing through the transistor. Due to that, the LED glows. This is indicated here. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video, means kindly share this video to your friends. Thank you.